Our help file for number 44 in your homework about projectile motion, projectiles that are fired at an angle. So what you should be seeing here is that we have a projectile, which is the basketball, that is launched at 40 degrees to the horizontal, and that is all we know regarding how it was launched. Obviously, there is some sort of V initial. I'm going to add it to the diagram. We do not know what it is. You're welcome to use V initial, V0, whichever is more appropriate for you. What I do know is the vertical displacement and the horizontal displacement of the ball. And you know that the first step that we always make for a projectile motion launched at an angle is splitting initial velocity into the components. Yes, we do not know what the initial velocity is. Still, we need to split it into components. So the first two variables that I need to obtain, the first step is I'm going to use sine and cosine. So since I'm seeing through this side, this will be my Vy, and it's going to be initial, and I will find it as V initial sine of 40 degrees, whereas Vx is the side where we close our eyes, so therefore it's going to be V initial cosine of 40 degrees. First step made, we have something. We have two equations with one variable in them. That's good. Now, I also know that my change in x is 10 meters. This is how far the hoop is horizontally. Now, I know that the ball is shot from 2 meters, and this place right here is 305 meters. So even though our ball went all the way up, and I don't know what this height is, and I personally do not care, and it doesn't matter for us. They didn't ask for it. We are not going to find it. We can if we figure out the initial velocity, then half time and all that. Who cares? We do care about the total final displacement. It started at 2 meters above the ground, ended up at 305 meters above the ground. So technically, change in y is your y final minus y initial as any change. So therefore, it's 305 minus 2, that is 105 meters. All right. So here we have our V initial cosine and V initial sine for our two velocities, and we have two displacements. How can we find time? I know that for the time, I have equations like change in t horizontally is going to be change in x over Vx. I do not know what Vx is, but I do know the expression for it. So I'm going to say change in x over V initial times cosine of 40. Now the trick here is, yes, I can kind of write the expression for halftime, but halftime has nothing to do with what I'm trying to find. I'm trying to find the time that it takes to get to the goal, to the hoop. And I know that my change in y is 105. So the formula that incorporates change in y, V initial, acceleration, and time is the time squared formula. So I'm going to say change in y equals V initial, mind you, that's V initial y, not V initial x, and not V initial total, times change in t plus 1/2 g change in t squared. And now the trick is, even though I do not know time, which is incorporated in here, I do have the expression for it, which is right here. So what I'm going to do, I'm going to do the substitution. I'm going to grab this whole contraption of x over V initial cosine of 40, and I'm going to plug it into this formula right here. So first off, we need to make sure that this little puppy here is appropriately written as V initial sine of 40. And then we can do some canceling, and it's going to all work out. So 1.05 meters is our displacement. It will equal to V initial sine of 40, which is all of this. So this V initial y is V initial sine of 40. Then I continue writing change in t as change in x over V initial cosine of 40. Now look how beautiful this is. I can now cancel the unknown V initial because one of them is in the numerator and the other one is in the denominator. Furthermore, for those of you who remember geometry and who are in pre-cal right now, you remember that sine over cosine is tangent. So I can then consolidate this to 1.05 equals change in x, which I know is, what is it, 10 meters, I believe. So that, and then tangent of 40, boom. And then I continue, this all is just this part. So that's what I ended up. I don't even have V initial anymore, which is great. Then 1/2 g, we know g is going to be downward, and therefore I'm going to make it negative, and half of g is negative 4.9, so negative 4.9, and then I have t squared. So I have to take the whole contraption of change in x over V initial times cosine of 40, all of that I have to square. And now we have one variable because change in x is a given. That's the beauty of this. We substitute and we get rid of the unknown variables. So overall, this boils down to 1.05 equals 10 tangents of 40 minus, you know that 10 squared is 100. 4.9 times 100 is 490. Then I have V initial squared, and then remember that cosine of 40 is a number, so I just need to square that little puppy. So now I pull out my calculator. You can rearrange it with formula first or just go ahead and get your numbers. So I'm going to go ahead and grab, since this is rearranging, I'm going to grab my contraption with V squared, put it on the left, and I'm going to grab 105 and put it on the right. And when you cross the line, meaning this line right here, the equation line, you change the sign. So overall, what I'm going to do, I'm going to say 490 over V initial. Well, actually, you know what? I'm going to do a shortcut. Let's do this. What is 490 over cosine of 40? And it needs to be squared. So I'm putting into my calculator. Make sure that you are using parentheses just in case. So the 835, which is what I get when I calculate 490 over square of cosine of 40, I get 835. So 835 over V initial squared, which is my only variable left over, should be equal to, and then I do 10 tens of 40 degrees minus 105. That gets me 7.34. And then, since I'm looking for something in the denominator, it's a simple swap. You want to get somebody out of the dungeon, you have to sacrifice something else. So there we go. We swap these, and I get V initial squared equals 835 over 734. And then if I root that, I end up with my answer. So ultimately, V initial in this case is going to be the root of 835 over 7.34, 10.7. So around 11 meters per second. Let me see, what are they? I think they're up to 3 sig figs. All right. Since they want 3 sig figs, we're going to keep it as 10.7 meters per second. Now the quick check. If I want to make sure that what I calculated is correct, is if this is 10.7, then this will be 10.7 cosine of 40 will give me 8.2. Then if I take 10 over 8.2, that'll give me change in t of 1.22 seconds. And then if I plug this in there, I will get change in y equal. So V initial is, what did we get? 10.7 sine of 40. So that's 6.88. 6.88 times my time of 1.22 minus 4.9 times 1.22 squared. If this turns out to be 105, well, that's money. 6.88 times 1.22 minus 4.9 times 1.22 squared, I got 1.1, which is good because I rounded on the way to this answer. So overall, what I just checked, this became, using these numbers, which I rounded. If you think 6.88 is 6.87, 6.877 and all that, so with rounding, I ended up with just a 5 centimeters mistake. But overall, this is how you do it.